In this problem, we're given a differential equation, and now we have both x and y on the right-hand side. So this is a little bit different than the previous two examples. We're still going to start this one off by separating the variables. To do that, I'm going to multiply by dx on each side, and I'm also going to multiply by 2y. Now you can do this in two different steps if you'd like, but it'll work in one. You can see here that the dx will cancel, leaving us with 2y dy on the left-hand side. And then on the right-hand side, I'll have x squared plus 2x, and the 2y's will cancel. And then we have the dx on the right-hand side. It's very important that you get something in terms of y on the left, along with dy. And then on the right, you need to have an expression in terms of x, and then a dx. When you've reached that point, it's time to integrate each side of this integral equation here. So we're going to find the antiderivative of 2y, which happens to be y squared. That's the power rule in reverse. So if you want, you can put a little 1 here. You can add 1, which would be 1 plus 1 or 2, and then divide by 2. So 2 divided by 2 is 1. That's why you don't see a coefficient here. On the right-hand side, we're going to add 1 to the exponent, which is 3, and then we're going to divide by that new exponent. And then the antiderivative of 2x is x squared. Of course, we need our plus c here. I like to go ahead and solve for c at this point. So we're given our initial condition here, f at 0 is equal to 2. So I'll write 2 squared is equal to 0 to the third over 3 plus 0 squared plus c. 0 to the third divided by 3 is 0. 0 squared is also 0. So we find c to be 2 squared, which is 4. At this point, what we need to do is go back to our, well, this is almost the general solution. We haven't solved for y yet. But we're going to go back to this line right here. And all we're going to do is we're going to replace the c with what we found c to be, which is 4. The last step here is to actually solve for y. So we're going to take the square root of each side here, and that's going to be y is equal to plus or minus the square root of x to the third over 3 plus x squared plus 4. We do need to make a choice now, and that choice is going to be completely dependent on this guy right here, which is our initial condition. If you want, you can resubstitute that initial condition in, and you're going to see what happens here if we do that. Now, if we sub the 0 in for the x, all those x terms are going to be gone, and we're just going to have 4 underneath. And we want this to work out. So which sign should we pick here? Well, definitely not the negative sign. We have to do plus or minus, well, the square root of 4 is 2, but we need that to be positive 2. So notice we don't want this negative sign right here. We want to keep that positive sign. So I'm going to take this line right here, and I'm going to select only the positive square root because that's what my initial condition is telling me needs to happen. You want to keep in mind what that initial condition is. That's right up here when you're selecting a positive or negative sign. That's going to happen when you square root or even root, and you'll also see that happen when we have the natural log because we'll have an absolute value in there. So this is your particular solution passing through the point 0, 2.